All right. Welcome to the IAG Thursday thing. This thing that we've been doing every Thursday for a while now. Now that we're on the podcast side of stuff, we're like what, 14 episodes in? I don't know. We're 16, 17 episodes in. This is the 17th episode. That's and we haven't missed a single week yet, other than the one that got drained, unfortunately. Nothing we could do about that one. But we made up for it. Either way, so this week, we have some fairly large Boogeyman announcements. And there's going to be a lot of questions about this. So what we decided to do was bring the tuner on. Welcome back, Graham from Boosted Performance Tuning. And we're going to have a conversation with Graham about basically when good engine management needs to be better engine management, or maybe like certain engine management fits what you're trying to do a little better. Basically higher level math needs to be done with engine management, and we want to do bigger things, and what we were using served us very well, but unfortunately is not going to be able to do some of the stuff we want to do. So what we want to do is kind of explain some of that and go from there. So Graham, how you doing this week?
Doing good. Staying busy. How about you?
Solid, man. It's been the first of the year was pretty nuts. It's been kind of crazy around here. We also got Warranty on. I love having Warranty on here.
Hello.
Warranty's been around the Boogeyman project before it even was at IAG. He's been coming to the track me along with Graham for a very, very long time. So we're all really familiar with this car and some of the stuff, the problems we've had and haven't had, and what we needed to do and what we couldn't do, or our limitations. And I think this was the proper three people to have this conversation with, because we're all really excited. So let's start with where Boogeyman is and what the situation is with Boogeyman currently. Okay, so Boogeyman started as I needed an ECU, and I was actually going to try to pull this off on a stock ECU, and Graham was like, "Oh God, no." Graham had a Haltech 2500 Elite that he was doing some testing on with his time attack car, and he had decided, because he was running drive-by-wire and a few other things, and CAN at the later cars run CAN. And if you want to explain CAN a little bit, Graham, so we don't lose everybody completely, but why that ECU at the time really didn't play well with what you were doing, and why it got passed down to me.
Sure, yeah. So real quick. So yeah, CAN bus is a communication standard that pretty much any Subaru that's 08 and newer uses. It's how like the DCCD, the ABS, the body control module, and the ECU all communicate together, rather than having a whole bunch of wires where every sensor is connected to everything that needs to see it. The CAN bus is just two simple wires that allow lots of information to be sent at really high speeds. The problem is that if you don't replicate all the OEM CAN bus communications correctly, both in terms of receiving and sending, when you replace the ECU, the other systems in the car won't work correctly. Long story short, at that point, granted, this is a while ago with Haltech, and they've come a lot farther. They've got CAN bus working a lot better now on the newer stuff. But at the time, that was a big hang up. And then some of the other controls in earlier firmwares that they had back then also weren't working very well for my car, and it just didn't feel like a good solution for 2008 plus at the time. But as we said, and as we've seen, it was better, far better than a stock ECU, and something that was easy to integrate right into your car.
Yes. Okay. So we decided at this point that most of the wiring that was in my existing chassis was kind of crap anyway. So we decided to use the Haltech universal wiring harness. What really sucks is right after this, both AIM, who use the dash display that I use, is made by a company called AIM. AIM and Haltech both released solutions that included a PDM, which is a power distribution module, that basically gets rid of your fuse box and everything goes through this. So we're still on a basic fuse box and everything, but we're on their universal wiring harness with a basic fuse box, and we built the harness from the ground up around this Haltech 2500. And to be perfectly honest, in our application, that Haltech was great. I mean, we won championships with it, set a whole ton of records. It did basically everything we needed it to do. I have the support we got from Haltech when we needed it was top notch. You know, I don't want this in any way to be a bash on what that product is and what it can do for the right people. But some of the stuff that we want to do in the future, unfortunately, the Haltech probably isn't the right choice for it. So Graham then started messing around. You started playing around with Motec for a little while, and that's one example of what's called higher end engine management. And then Emtron. I don't know. Did you end up having a couple customers with Emtron? You are the reason I ended up starting talking to Emtron.
Yeah, so I'll give you the quick rundown on this actually. So yes, looking for something that was going to integrate a lot cleaner with CAN bus and just work a lot better all around, I went to the Motec ECU and I specifically got the plug and play kit from John Reed Racing. John Reed's become a great friend of mine. I talk to him all the time, and he actually supplied the plug and play ECU kit for the side by side as well, the YXZ that's got turbo on it. So he's been great to work with, and so he provided the plug-in ECU, and I was able to, kind of figure out how to use Emtron, put together a map, and start it up. And it started and ran. It was on the dyno, making full throttle pulls in about 30 minutes. And I was blown away. I was like, this is what you really need. You need some engine management that can do everything as well or better than stock. So I used that for a long time, and it was fantastic. And it was sat on my car for quite a while. The jump to Emtron was basically kind of two cars at the same time, both Subaru powered, both really interesting. And they were both through Six Star Motorsports. And ironically enough, at the time, our old pal Mark over there was actually the one that, kind of like said, hey, let's try out Emtron. And I was like, oh, I've looked at it. We've never,
Oh man. Yes. In fact, you and I both kind of fought it.
Yeah, so we had talked to them. We talked to Nicholas, who I talk to all the time now at Emtron. We talked to him at SEMA, and we saw the product, and we saw it was pretty good, but it was just kind of like, it needed some things. It was, It just wasn't quite all the way there, and they had a lot of stuff in the pipe, and we're like, okay, well, let's circle back to this and kind of check on it later. Well, by the time it got brought back up for these two projects, I'd circle back around. I'm like, oh, cool. They have pretty much 90% of the things that I was looking for that I felt like were missing to want to jump into this. So we did these two projects kind of side by side. One of them was that 760 horsepower 2010 Legacy GT. Remember that rowdy thing?
Yep.
Where Six Star did the custom GTX 3584 turbo.
So people understand which one that is. That's the front mounted turbo. Yep. That's it. Yep. So that's the goofy EJ with the like the FA style turbo down in the front.
Yep. And Six Star made the custom turbo kit to fit a 3584 kind of up a little bit behind the passenger headlight, I believe.
Yeah.
Or something.
It was up in that area. Yeah.
But anyway, we needed a way to tune that car, and it turned out that Emtron had the ability to run that car and to do the CAN bus and everything. So we ordered it kind of on a whim, and I spent many hours on that car getting it all set up, and it was my first really big horsepower Subaru that we did, and it all came together really well. The car ran and drives amazing like stock, but makes a crap load of power, has all the engine safeties. So that was one project that kind of was like, wow, this is really good. The other one was that Subaru powered Saker sports car that,
yes. Those guys were always great to work with, and they were really...
Yeah, they were using these really archaic old Emerald ECUs.
They didn't even have O2 sensors. There's not even
exactly. They didn't even have crazy. A wideband. Yep, there was no fuel control. There was no knock control. There was so little in there. It was a joke. It was like basically running an 80s four-wheeler. That's or 90s four-wheeler with fuel injection.
5-speed transmission, front-wheel drive only. But for them, it was the back of the car.
Very, very, very basic. And, every time, like, we put the car on the dyno, and we'd get it perfect. But then he'd go race it, and it was a lot colder, or it was a lot hotter, or things would change. And it was such a challenge because we didn't have any data. We didn't have any type of good temperature control. And finally, they wanted something better, so we talked to them about Emtron, and we set it up with an Emtron, and then they sent the car out to me in Iowa, and also added like paddle shifting and gear shift control, needed all that stuff too. And we set it all up, and now that car is amazing. He can actually take it out and enjoy it. If there is something funny with it, he can send me a log, and within a few minutes, I can tell him, oh, your fuel pump's going bad, or, oh, I think this vacuum came off. And, he can even look at the logs himself and troubleshoot some of this stuff himself. So it's made supporting that car and made him enjoy that car on the track 100 times more than he did before.
So that was going from, essentially a calculator trying to run a engine to, higher end engine management. So let's fast forward to that. Now you've started to mess around with Emtron. You got interested in it. You even didn't you run one on one of your own cars?
So I was so impressed after these two cars and wanted to take a deeper dive into some more of the functionality, like this, exactly the same stuff we're going to do on your car as well as on our car. So we did sell the Motec, and we picked up an Emtron and have that in there now. And I've already got it up and running and driving, and a lot of these features already starting to kind of work. I'm in progress of getting some other stuff set up, and I got some intercooler pipe made, but we'll have the car out this year to really push it. So, but I spent some time on it in our own car to kind of refine some of the drivability, the startup, the idle, the push it out, let it sit overnight on E85, hold start right. All those little details. I was 99% of the way there on the Legacy just with the time I had, but it's always that last 1% that really makes a difference between an okay tune, or one that sure it might work for a quarter mile pass, and the one that starts up and runs and you're surprised it's not a stock ECU anymore. So to get that 1%, I had to put it in my car, and I had to spend some good hours on it to dial in all that little stuff. But now at this point, you saw that 2016 STI that I shared about recently. That car, you would not know that car has a different ECU in it. It runs and drives as good or better than stock, even on big injectors, but has all the motorsport safeties. He has the ability to change his SI drive. Instead of just changing boost, he actually changed it for the different purposes. He's going to drag race that car and road race that car and do some half-mile racing with that car. So he can use each mode to dial in for that type of racing without having to upload a new map.
Yep.
He's got the rolling launch control. He's got the motorsports launch control, where it builds boost and holds things nicely. He's using a ton of that functionality, and it's amazing.
Can we go back a little bit to that 1% that you glossed over, but I think it's worth emphasizing?
Sure.
Cold starts on high ethanol blends, stuff that is common knowledge that people think is just hard to do or impossible. You figured out how to do it, and it's just adjustments like anything else in a tune. So we went from impossible to pretty darn easy.
Well, I mean, to Graham's defense, he's actually been pretty good about that, living in that environment himself, but plus like doing that on stock ECUs, but being able to just do that in general is that's a testament to solid tuning, in my opinion.
Yeah.
So you started messing around with some of the new functionality. Now here's where we get into this. Boogie, we've been doing this forever. A lot of these same things that you're saying, well, we've got an Emtron, you can remote in and find stuff on my ECU and things like that with my Haltech, and it's solid. You can complain about the software or whatever you want, but your way around it enough. If somebody's really familiar with it, they're going to get around just fine in it. It's a capable, we have a bunch of motorsport safeties built into it. There's, a lot of that stuff exists. What the question really is here, why would somebody like me want to leave, or would it behoove me to leave a perfectly good ECU, a Haltech, a Link, something along those lines, and go to an Emtron or a Motec? And in this situation, I'm just flat out, we're going to an Emtron. So we have a new partnership with Emtron, and we're really excited to do some stuff. And I want to get into some of the crazier things we're going to do later, but like on like a broad scale, why would somebody sell this to me? You know what I mean? Tell me why I'd want to plunk down and go after this.
Sure, I can. Yeah, we'll do the real high level answer now, and then we'll dive into the detail. But their high level answer is really two things. It's do you want to have 70 to 80% consistent perfect control, or do you want to be a lot closer to 100, and that translates to picking up time in every section of the track to go faster? Do you want to go faster with more consistent fuel control and torque control and more consistent engine management?
What's causing that though?
Well, we'll kind of get into that. I think that's a deeper conversation. But
okay,
if what I would just tell you if we were starting this conversation is that from experience of using all these different ECUs, I can tell you that the control, the fuel control, and then the ability to use the torque model and the way the engine can be ran is better and creates more consistent behavior when you put your foot down, essentially. You as a driver are going to feel like this car is smoother. You're not going to have the likelihood of stumbling into a weird area, part throttle, high load coming through a corner. It's going to be, the airflow can be calculated better, and you're going to put your foot back down and have a better response and gain some time through lack of lag. I would tell you.
And that has happened.
The other big thing I will say is the data on the back end to diagnose issues. There's been many times where I have a pretty good idea of what's going on with the data that we get logged in on board with the Haltech, but it's not nearly as fast and as much as I really need to see some little details. So the other thing I would tell you is that the data I have at my disposal to go through and comb through after a session is significantly better and much more likely to be able to troubleshoot issues faster.
Okay.
So you would rate it at 70% of the capabilities on an otherwise high-end ECU. So that
I would, when what I'm
30%.
rating is let's call it accuracy of running the engine. How accurate is the airflow calculated at all throttle positions and all boost levels versus, what can a different ECU, how can it calculate better? And that's kind of what we'll dig into a little bit more. But the calculations, it's at the beginning, Dewey said, we're doing more math. It's more of that modeling. There's a lot of things that are modeled really well. We've got turbodynamics, we've got torque calculations, and we've got airflow calculations that are on another level and allow us to really dial an engine in even more, even better. And
so when you say turbodynamics,
what's that?
When you say turbodynamics, explain what you mean by that.
What we can do with Emtron by giving it the right information of pressures and temperatures and turbine wheel speed is we're going to be able to know exactly where on the turbo efficiency map the turbo is operating at all times. So in other words, like the German style ECUs, a lot of those have this type of modeling built in, and that's why their fuel model and their boost control is so amazing and accurate. We're going to have that ability with Emtron, with your car and my car, to know exactly where the turbo efficiency is, to know if we're going to be running over the surge line and running into compressor surge, or to know if we're running outside the efficiency edge of the turbo. We can keep it where we want.
This is where, compressor maps and stuff start really coming in handy.
Exactly. We're going to basically have a digital compressor map in the tuning model to use to do things like operate your anti-surge valve to make sure that your toe speed stays up, but you don't have compressor surge.
That is where we're going next. So one of the things we want to do, one of the things we really want to do is not only do we want to implement a electronic wastegate, so it's no longer actuated by vacuum. We're talking about doing the same thing with the bypass valve, but it's going to operate differently. So the blow-off valve is going to function drastically different. This is something we're hopefully going to have implemented, right out of the gate. I know you're starting to play around with this now. Can you kind of explain the concept of what the mad science? Because Emtron's very excited about us doing this, and the more they talk about it, the more you talk about it, the more ridiculously excited I'm getting about it.
Yeah, one of the biggest pieces of feedback I've gotten from the people over at Emtron is that they're really bummed that people love Emtron and they're using Emtron on all these crazy builds, but they're not using all this really cool stuff. They're just using it like they would a stock ECU, and they're super happy with it. And it does all that extremely well. But when I tell them what we're trying to do, and just like as you did too, they're like, "Oh, thank God someone's going to use all this turbo modeling we did the math for." They have hours and hours and hours into this, and not a lot of people are taking advantage of it. I think partially because it's challenging to understand and it's challenging to implement. And they have great documentation, but it's still tricky. It's also obviously a little bit expensive because you have to invest in more sensors, invest in more wiring. Yep. So it's not exactly like a Subaru has any of these sensors to begin with. We have to add them all. So there is certainly that. But yes, we're gonna dive in. We're gonna use all this, and I think you wanted me to specifically talk about the anti-surge, right?
Yes. So there's some things that we're going to. First off, there's some sensors that are going to be added in. We need a turbo speed sensor. Okay. Yep. And there's other stuff we're going to need to add in. These are things that there's no possible way to do these on a stock ECU. Yep. And like what we're talking about doing here is very, very exciting, especially from a time attack standpoint.
Yep. So the real quick overview on the sensors needed. You need the turbo inlet and pressure. You have to know, turbo inlet temperature and pressure. So you have to know the temperature of the air getting pulled into the intake to the turbo and the pressure. And obviously the pressure is going to be generally atmospheric, but if you're running a turbo inlet, which you should be, so you have a filter, there might be a bit of a pull down on the pressure. So you have the pressure before the turbo. You have the temperature coming out of the turbo before the intercooler. And then you have a pressure and temperature sensor, a TMAP sensor in front of the throttle body that basically provides the pressure in front of the throttle plate as well as the temperature, which becomes a main component of your charge temperature. And then, as you mentioned, turbo speed. With those variables, it can calculate the pressure ratio of the turbo, and it knows the speed, and therefore it knows, again, where it's at on the compressor map. The value of that is that we can essentially have an electronic bypass valve of some kind. I'm going to test the one from Turbo Smart that's got the little boost controller built in the top, essentially. We're also probably going to be doing some testing with very small drive-by-wire throttle bodies, so we can open them up, a bit more exact.
I've heard people are modifying like small Bosch throttle bodies to do this.
Yep. A little 38, like a little throttle body from like a little tiny engine works perfect.
Yep.
But the idea is that if normally, let's just think about when you're going into boost, you go full throttle, the boost builds up. Most people, when they're done making boost, they lift all the way off the throttle, right? And at that point, you've got a bunch of boost pressure built up behind the throttle that closed. It has to go somewhere. So you've got your blow-off valve that opens because it's got a boost reference line on top that's hooked up to the intake manifold on the other side of the throttle body. So when you're full throttle, boost is holding it closed. As soon as you close it, the vacuum and the lack of boost essentially opens it up and whoosh goes all your air. The problem with that is, even if you lift a little bit off, a lot of times one of two things might happen depending on where you're at, what your turbo size is, and everything else is you might lose too much boost pressure. You might lose a lot of your boost and lose your turbo speed before you get back on the throttle again. Or it might be the opposite where you lift off a little bit because you need to scrub some speed for a really high speed corner. But what happens is the air has nowhere to go. The bypass valve's not opening up yet because there isn't enough differential pressure to do so. But the air is trying to flow backwards and surging against the compressor. And that's not good either. We don't want that condition because it creates,
it's a choppy really rough feel. On the turbo. You can trash bearings.
It creates a choppy feel, and you can lose some shaft speed as well. Ideally, what you want to do is figure out when you're starting to head past the surge line and open up the bypass valve a little bit electronically to let off some of that air, let it go somewhere, but keep your turbo spinning. And then the moment you're back full throttle again, you close that valve and you've got instant torque response back to continue on through the corner that you lifted for.
So basically it keeps the turbo spinning, okay, at a given speed, whatever speed you're trying to maintain with it, by just slightly letting out the amount of the least amount of pressure it needs to, and maintains exactly what it needs to. So in a way, I'm not saying it works like anti-lag, because anti-lag works on the exhaust side by basically forcing the turbo to stay up at speed, but it's kind of like the opposite of anti-lag by not letting the turbo slow down.
That's exactly right. Right, exactly. We're not doing anything. Now, we can certainly talk about anti-lag and that side of things, but all we're doing in this case is we're assuming that your you've got enough throttle into it. You've still got a lot of exhaust flow. You're just creating more air from the turbocharger that can actually go in the engine because you needed to close the throttle a bit to reduce the torque.
Yep.
And opening the bypass valve a little bit and letting it maintain that shaft speed that it wants to maintain, but let the pressure go somewhere so it's not surging is exactly what we want to do. That's the more ideal way to handle that scenario.
And if you're
So Josh Aldrich in the chat is asking, are you guys trying the charge air control valve or the ALS valve? I'm assuming the charge air control valve.
This is the charge, basically charge air control. It's, the term I like to use, there's different terms for it, but I like to call it like it's either air bleed or anti-surge is the main two pieces of terminology. You're bleeding off some air on the charge side.
So if we're losing that, we're also essentially just getting rid of the bypass valve. Can this thing, and again, this is now we're kind of wandering over into
hardware. We're not getting rid of the bypass valve.
So the bypass, the bypass or blow off valve will still be there then?
Yep. So if in the case, like let's talk about this Turbo Smart EM valve that I have for my car.
Okay.
It still has a vacuum line on the top. If I don't hook up the solenoid on top, it just sits there open and it operates exactly like a normal bypass valve.
Okay.
What the boost control solenoid allows me to do is if I'm in a situation where it's not going to be opening the bypass valve pneumatically, it can bleed off some of that pressure to basically get to a point where it will crack the valve a little bit and keep me from going over the surge line with the turbo.
I have two questions.
And it can do both, and this is one single unit instead of having to do a bypass valve and a small throttle body.
Oh yeah, so I'll only control that solenoid to bleed when I need to. Otherwise, when I do a full throttle lift, the solenoid's not going to be doing anything, and it's going to allow it to do a full blow off.
This is sick.
So I'm gonna be testing that.
This is so cool.
I'll be testing that with my car. I want to see if one of these valves can be enough to do what we want to do for our application.
So here's my next question. How much of a pain in the ass is it going to be to set this up?
To set up what? One of these
like you're going to have to model this thing out, and it's going to be a lot of like partial throttle stuff and weird I'm assuming this tune when we start is probably going to feel like really good, but it's going to get exponentially better through the year.
What's your first race year?
I was hoping to do Carolina.
Okay.
Yeah, well, we're shooting for Carolina. But it may be Rev Up.
Yeah.
But Rev Up is what I really want to go for that damn record.
So my goal, one of my goals here is to try to be able to get Nasty to rev up, to have some fun with it there and to test it out. But that means I have to feel extremely confident and have done a ton of testing for that. So hopefully both of our cars will kind of develop in parallel here. But yes, to answer your question, it's going to be a lot of time on the dyno, figuring this out, and getting the inputs right, getting the control right. And then we're going to have it close and we're going to go to the track and we're going to fine tune at the track. Yep. Essentially.
That's the only way we're going to be able to do it.
I don't think it's going to be too difficult. And, really, it's like the nice thing is we've instantly got that 70 to 80% perfect control right out of the bat, right? We're going to have that. All we're going to be doing is trying to chase that last percentage. And if it's not working, if it's getting in the way, no big deal. We turn it off, we move on, we come back to it. So not like it's going to hold us back. It's only going to be something where we're going to just have to play with it until it gets us what we want.
Yeah. I'm psyched about it, and I'm really psyched that we're doing some newer and exciting things. When it kind of sucks when people think everything has been done on, a particular platform, Subarus in general, like there's nothing new to do on an EJ or whatever. And then we have this conversation, and how exciting is this? And let's just think about even 5 or 6 years ago, you and I wouldn't have been even having this conversation. Like we were excited just to get proper boost control.
No, we had no idea. We had no idea this was a thing. Electronic bypass valves, and then we haven't even started talking about it yet. But electronic wastegates.
Yes. So let's actually wander that way. So now they also okay.
Before I touched on this Turbo Smart electronic valve and how it works, but I want to answer your other question about what if you were using a small throttle body, would you still have a large bypass valve?
Yes.
And the answer is I think we still want to use one so that, again, on the full throttle lift, you still need some fast, non-electronic way to dump the air safely. So you would still use a bypass valve. We would just use the small drive-by-wire throttle body as the air bleed.
Now, is that for safety features? Because, throttle is going to just click open instantly.
Well, throttle body, actually, there's going to be a slight bit of delay to get it open, but most even blow-off valves, they don't have to open a ton to let off a lot of air. But either way, I think you would want something just mechanical as that, like literally as a pop-off. Yeah.
Yep. I'm not saying it can't be done with a throttle body. I've asked a few different people about it, what their recommendation was based on experience, and the feedback I've been getting is that it's a good idea to still have a regular blow-off valve in the system.
Yep. No, that's super exciting.
Yeah, that makes sense. I've got 2 questions if you guys got a second.
Sure.
All right. Number 1, you mentioned a while ago turbo mapping. It sounds like you have to build that into the tune. I was thinking it could be canned by Emtron for a particular turbo model, or maybe handled generally by their airflow model to make your life easier when you're tuning it. You're thinking you're going to have to go explore every one of those weird edge cases to get the turbo mapped correctly?
No, not exactly. Not exactly. What you're essentially, excuse me 1 second, I got someone at the door here. I'm sorry.
So, long story short, you also have to remember that different turbos react differently on different engines. How a G35 1050 like is on my car is gonna function differently. It's gonna make boost at different RPM. It's gonna flow different amounts of air at a different boost differently on an Evo than it will on our car. Now, with that stated, I still think there is something that can be I'm kind of with you. I think they might be able to give you some sort of starting point. And maybe that's something that's coming, maybe they would work directly with Garrett, and find some way to input their compressor maps over into however Emtron would need to eat that. You know what I mean?
Now, you say...
Okay, my apologies, guys. I'm back.
All right.
Turbos act differently on different engines, but it's not the turbo's fault. The physics doesn't change. What's going in, magic happens, what's going out. It's the design of the engine, which Emtron should already have modeled.
Well, hang on, Warranty. Let me try to help clarify some of this for you. I had said that we're kind of creating a turbo map in Emtron, and that's more like fundamentally, okay? We still, for any given tune that I'm going to do that's going to use the turbo modeling and use air bleed, I am going to have to sort of have a set of tables that I drop in for different turbos. If it's a smaller 30R, or if it's a bigger 35R, or if it's a 40R, it's gonna have a different surge line. So I'm gonna have to basically look at the turbo map myself and set where the surge line is to trigger the solenoid to operate. So no, it's not going to be so simple. Like there's a drop down. Like I'm running a GTX 3584 RS with a 101 AR housing. That would be cool. They could theoretically do that, but it's not. That's above and beyond the scope of what they have in here. So I as the tuner will have to go in and manage some of that, but it's not going to be super difficult, and it's not going to be like this whole spend several hours on each specific turbo. Once you have the framework set, it's just going to be small adjustments to account for each turbo. Does that make sense?
Yeah, I got it. And that's what you were doing already with a repertoire of these are all the builds that I have, and I can take what I've learned from 1,000 stage 2 cars and make life a lot easier the next time I touch a stage 2 car.
Essentially, yeah. Once you kind of lay the framework, once you've done one, the next one's easier, and then the next one's easier, and then it just becomes like, you drop it in, and then you start to it's less setup time, and it's easier just to go straight into the tuning. You jump straight into the tuning.
Right, exactly. And it's not, for those of you playing along at home, it's not copying and pasting. I've seen it with my own 2 eyes. Graham just starts from a known good configuration and then tunes it for the particular engine that he's talking about.
The copy and paste is in the setup. The tuning is where you are adjusting it if you're adjusting it correctly for each car, each setup, and so on.
Right. Okay, I've got one more question if you've got a second. So
Yeah, send it.
do you continue to need an anti-lag system with this air bleed system besides, let's say, boost on the line? If you're out there driving, do you need an anti-lag system between corner to corner?
I may be able to answer this, then I want to try it, and then you're going to back me up. Because, long story short, anti-lag is most anti-lag, and when we're talking about anti-lag in general, that's based on the exhaust side. So that's the concept of anti-lag is to maintain as much exhaust gas energy as you can. Now, if we're talking extremely low RPM, the turbo was never at the speed this was going to be valuable. So what that's doing is you're off the gas, and you're actually off the gas for a decent amount of time. Anti-lag is basically blowing up fuel inside of your exhaust to keep your turbo spinning, so the second you hit the gas, it comes back on. It's also why anti-lag is extraordinarily hard on valves and extraordinarily hard on turbos. This won't be. This will actually make your turbo more reliable. And in a track situation, anti-lag does borderline nothing because you're always at a higher RPM and you're always basically at speed. This is kind of like maintaining turbo speed on the other side of it, the fresh air side of it.
Yeah. Now we could use this. There are time attack cars over on the other side of the world that do use, a rally style anti-lag approach, and that would be basically where when you lift the pedal for the corner, the throttle stays open, but the torque goes negative. And by that, I mean it does fuel cut, spark cut, ignition retard, and it maintains turbo speed because there's still explosions happening after the valve, but you lose the torque so you can go through the corner without dying. And then when you roll back on the pedal, the throttle's already open, it snaps the torque back in, and away you go. If we want to grab, if we need a couple more seconds out there to catch up with Jackie Ding next year, we can use that.
Don't say that ever on here.
but it comes at a cost. It comes at a cost going valves. So I'd recommend getting that Garrett sponsorship locked down first.
Yeah.
And then make sure that JJ is cool with some melted valves here and there, and we can do it.
Yeah, I mean, I can only think of one corner. Honestly, and I can only think of one corner that would be like huge. Okay, that would be absolutely massive. And the track, we aren't even running it this next year. And that would be, that would have been Heartland at that very last corner where you drop down into like the gut of second before you hit the front straight going towards start finish. We don't have a lot of like, I guess there are some situations where there are some fairly slow corners that instead of you having to drop a gear, you could leave it in like third instead of going to second. But man, at what point you got to ask how much is it really worth it? I don't know. Maybe a record. We'll see. I want to go sub 130 real bad. So
now the cool thing is we, anti-lag doesn't have to be a on-off switch. We can dial in a light effect, where we're not getting super aggressive with it necessarily. So we'll, it's things we can tinker around with, but yes, the focus to begin with is going to be on using anti-surge. I think that's going to be a big step forward for the car.
Dylan and IAG, spare engine, got it.
Yep. Bring that.
Yep, we need to get in on that Inconel exhaust valve and Inconel. Well, I guess the new Garretts and whatever they're using for their exhaust, their turbine wheel, supposedly puts up with anti-lag fairly well. That's actually one thing that, we're kind of going off topic, that the IHI turbos, like the VF turbos, they've got really beefy bearings and supposedly put up with like rally style anti-lag fairly well. You're gonna go through them, don't get me wrong, but like you'll make the event or two before you've got to replace it, which is kind of, I always thought that was interesting that those turbos, like, they're kind of inefficient everywhere. VFs just generally are kind of an inefficient turbo, at least Subaru based VFs, but they can eat anti-lag.
Well, they work well for that rally purpose.
Spaz, Valves or Records doesn't have the same ring to it. It just really doesn't. The Records or Rods sounds way better.
Question from the
Um,
chat a while back. Is it can it be street legal using an Emtron?
Okay,
No.
I'm going to go into this real quick. Here's the reality of this, guys. Anytime you touch something that is controlled by the EPA, you're playing with fire. Okay, if you're to put an Emtron inside of your car, you are no longer emissions legal. And the EPA is a federal organization. Okay, that's all 50 states. You're not illegal in just California. If they don't check your car, you are still technically illegal. Okay, just need to make sure that you guys do understand what we're talking about is race car stuff. Okay? This is race car things. And like Sean just said in the chat, EPA don't mess. And they do not mess around. And this is why if you come into somebody like Graham, and this conversation is about this is high-level race car crap. I try not to do a ton of these, but man, this is just way too exciting to not do it, and it's a lot of fun to talk about. But it's if you go to somebody like Graham and you go, hey, I want to do all this crazy stuff. I'm going to run an Emtron. Here's my street car. I'm doing this for roll racing down the highway. Graham's going to tell you no, and you can't be mad at that. And I don't blame him for that. So take without what you may. This is for race cars. So did that pretty much answer that? Did I cover that for you, Graham? So you don't have to get your butt in your panties in a bunch?
I mean,
okay.
if you take the ECU, you take a stock ECU out of your car, you've made your car not legal for the road. Period.
Yeah.
In all 50 states. Now,
there's no such thing as an aftermarket.
You can actually no. This is kind of crazy, but in a lot of states, even crazy enough, in California, I have some guys in California with actual exemptions for their cars. Even California will grant exceptions, like those 818 cars.
Oh, because it's like a kit car, and there's like not many of them.
There's some stuff like that. Illinois actually has show and display. There are actually some legal avenues to be able to take the ECU out of your car and be, basically, you don't have to do emissions with your car. It's difficult. You're not going to get it on your brand new Subaru that you daily drive. That's not going to happen. But if you go through the right legal process and you indicate that your car is basically not used as a regular road going car, essentially, in some states you can do that. And we have customers that have gone through those avenues. Otherwise, the majority of what we're dealing with is cars like yours. It's people that take their car to the track and that's it. They bring their car on a trailer for tuning. They trailer their car to the track for racing it. They trailer the car to the airport for the half mile. They're not driving these cars every day on an Emtron. That's not its intention. That's not something that that you can do and that we can do for you.
Now,
you're doing this as a race car.
What I am going to say though, and you take this any way you want, I really, really like that my car can drive around the pits extremely nice. It starts nice. It drives nice. It's nice and smooth. It tells me if anything's wrong with it.
What'll be really cool is, when you're doing those
station in the pits and put whatever fuel I need in it because, flex fuel works correctly natively in it. It's really nice in the pits that all of this stuff just works really well. When
you're doing those roller shots out on the track, you can turn on cruise control with Emtron and have cruise control and just sit back and
there you go. Because if you're on the track, and you those rolling shots, your foot will get tired. Okay.
Yep.
So these are good things to know. It's nice to, it's good to know, why throw everything away if you don't have to? If you can have creature comforts, why wouldn't you want them?
It's just absurd. It's crazy.
Just throwing that out there. Okay. So back to some of the other goodies. There's probably more to this that I'm not seeing. Is there anything else that you're like really excited about with this, other than our wacky boost control concepts that we're talking about?
Well, yeah. So the other big thing that we're going to do on your car that I'm starting to do more on other cars, including our own, is what they call the throttle mass flow air calculation. So most people are familiar with the two primary forms of airflow calculation, one being a mass airflow sensor, which all Subarus have that sits in the intake after the air filter and is basically a wire that gets heated and cooled down by the air going past it. And the amount it gets cooled down calculates to a volt or goes to a voltage, which goes to a grams of air coming past it. So okay. In other words, however much air is moving past it cools down the wire more and tells it there's more air there. That's mass airflow. That's pretty simple, pretty straightforward, pretty accurate way to do things, but has limitations that with higher horsepower and also has issues with turbulence in front of a turbo, things like that. So mass airflow
or
is great.
Boost leaks.
Yeah, yeah, exactly. Boost leaks are, the air comes in but doesn't go in the engine. So mass airflow can be really great on a simple car, and that's why Subaru and a lot of manufacturers use it. The other primary way to calculate airflow is speed density, which is using a calculation that involves the temperature of the air, the pressure of the air, the size of the cylinder that you're filling, and some other variables, the ideal gas law, and calculates the amount of air going in the engine based on those variables instead. That is more immune to, things that might affect a MAF sensor and basically gives you, infinite amounts of airflow calculation beyond the voltage limits of a given MAF sensor in a tube. So it's really nice. The problem with speed density is that, you can use a throttle component to kind of trim your efficiency for part throttle, but it's not the most accurate way of calculating airflow. So enter a third type, which Emtron is one of the few ECUs to actually have a model for, which is called throttle mass flow setup. And basically the calculation here is sort of speed density in one way, but it blends over to speed density at full throttle, because when you're at full throttle, this model no longer works. But basically the way this model works is you have pressure in front of the throttle plate, you have pressure after it, you have the temperature component, and then you have the angle of the throttle, and you have a calculation of basically the amount of area when the throttle is at part throttle positions. And using all this math, they can really accurately calculate exactly how much air is passing past the throttle at part throttle. So all those areas on the track you feel when you're at weird throttle positions, moving on and off, and the boost pressure is doing different things, and the car feels kind of gross, and we can't get it perfect because we only have speed density.
I can tell you the exact corner that I feel this at. You feel this all the time at Lime Rock. Because you're at goofy partial throttle, especially turn 2 at Lime Rock, which is the only left-hander. You're in this goofy part throttle situation. You're doing what they call maintenance throttle. As a driver, this is what that would be called, as maintenance throttle. And in a turbo car, maintenance throttle is a nightmare. And what you're saying should take care of that.
Yep. It's a problem for two reasons. One, compressor surge, and two, airflow calculation. We're going to solve those two big things with Emtron, and it's going to make things night and day different for you in part throttle conditions. And that's going to translate to more consistency and more time.
That's time. That literally is just time. Like that to me, I truly believe that'd be like adding 150 horsepower to the car.
Yep.
That literally is going to be that amount of difference in time.
It's going to significantly change how the car feels when you drive it. It's going to not feel like a turbo car.
I'm so stoked. So one of the things we are doing, and a lot of people don't even realize this too, is Boogie is still on a cable throttle. Okay, it is. People have no idea how basic this damn car is. There is literally essentially a damn string that goes from my throttle pedal to the throttle body and just opens it up. So, I can't. I've been so hard fighting this for so many years, but you've proven it. And time and time again, my biggest problem with going to a drive-by-wire throttle is if you drive most cob-based drive-by-wire setups, they feel there is a lag between what your foot is doing and what the engine is doing, and a drive-by cable doesn't feel like that. But then you've put the first one I ever felt. You put a Motec in Filippo's car. It was a 20 GXTR, street car, basically.
Dom 1.5.
Dom 1.5. Either way, it was like a low 400 horsepower, whatever. and went from a really nice Cobb tune to this Motec, and it was immediate. And so what we found out is the stock ECU has some sort of like filtering. Yeah, and in the second that went away, that felt so good. And so I fought it for years, but we are going to drive-by-wire. What I want you to talk about now is some of the advantages of going to drive-by-wire versus drive-by-cable and some of the cool stuff that we might be able to do with it from there too, from a reliability standpoint and performance.
Sure. Yeah. So drive-by-wire is really awesome when you get it all set up correctly. You can have much more dynamic throttle mapping. So you know it's not just whatever you push with your foot is whatever the throttle plate's going to be at. You can do situations where the first 70% of the pedal travel can get you full throttle, and the last 30% will command different amounts of boost or torque. And to that same degree, you can also at this point take advantage of Emtron's torque model and basically drive your torque request off of your throttle, much like modern OEM vehicles work. So then you can actually dial in torque more accurately using your foot. And throttle isn't just a component of your foot anymore, it's a component of the torque model. And that just makes everything much more accurate. Also allows us to, do softer cuts, do engine safeties where we pull the throttle down.
This is where I wanted you to kind of get into. So there's a mechanical safety side of this. Yep. Not so much like the ECU controlling stuff, but there's a mechanical side of this that, like, if we're doing things like flat foot shifting, auto blip downshifts, things like that, this is going to start coming in very handy.
Yep.
Auto blip is something that I've been fighting for years because I'm not going to lie, I'm pretty damn proud of how good I am at heel toe, and I'm solid.
Agree.
But what I would really like to be able to do is have a solid foot on the brake, heel towing. And I think that's going to net time. And it's also, I've been getting used to it in the BRZ, training my brain to do it. A lot of it's just force of habit didn't allow me to not kick my heel over and blip the throttle. That's going to be easier on the transmission. And that's less synchros I'm destroying, less, it's less time that Dylan's got to spend repairing this car between events.
Yep. So that's a new thing that just came out in the latest firmware. I'm super excited about, and that is the downshift rev match model. And instead of just doing it, some other ECUs, like I have this working on Link in the GC that we have, and it's pretty good. But it basically just all you do is you sort of just ask for X throttle opening at Y time. It's not very dynamic. What's super cool about the Emtron is they've leveraged the whole torque model, and they've also calculated output shaft speed using your gear ratios and your input shaft speed, essentially. And they're not necessarily, they're actually calculating the perfect RPM to rev to and hold at. So it is a complete like OEM feel dynamic downshift rev match model where it's at the right RPM at the right time every time.
Heard an from Dewey.
Oh, sorry about that. I just had an issue with my headset and it just lost its mind. Okay, I'm back. We're good. I am so sorry.
Did you catch everything about the rev match? Because that was
you've got to go back over it again. I want to hear it.
Okay, so here we go. I'll start over from the top. So other ECUs do have a rev match concept, but generally it's just based on you're asking for X amount of throttle opening at Y amount of time. You're just asking it to go to this for so many milliseconds, and it kind of gets you in the ballpark. It's better than nothing. Emtron did the Emtron thing and used torque modeling and used output shaft calculation and your gear ratios to essentially figure out the perfect RPM to be at any given time you need to downshift. And it uses the torque model to rev it right to that RPM, hold it there for you where you need it, and let you make the downshift cleanly. So it's an OEM feeling dynamic model, not just
that is going to feel so nice.
Yep.
And that's honestly, that's one of my biggest complaints about the BRZ is it doesn't work like that. And if you're not at the exact RPM it needs to be at, that blip amount sometimes doesn't match up, and it doesn't feel great.
Yep. Now, I will say there is a caveat to this. There is a limitation in the fact that we don't have a gear position sensor output. So the Emtron doesn't have any way to know when you have made it into the next gear. I don't know if you haven't driven a GR Corolla yet, have you? And you're going to yell because I didn't let you drive mine. But when you drive one of those and you try the rev match downshift, it's going to blow your mind, because you're going to realize that no matter how fast or how slow you downshift, the rev match is perfect. And you're like, how are they doing that? And the answer is there's an output on the transmission of the gear position. So it knows when you've clicked into the next gear and it stops rev matching.
Yeah. So how do we get that on a Subaru?
Sequential gearbox.
Yeah, there's got to be a way.
I don't think maybe somebody in here knows of a way to add
what if we put a strain gauge on? A strain gauge is going to know what direction I'm pulling, right? Or does it only know?
That doesn't solve the problem. It doesn't know when the next gear has been engaged inside the transmission.
Okay, that's fair.
So that's the trick. It's gear position. It's based on it should be output shaft speed of the transmission, I think is what they're looking at, and I could be wrong on that. I don't, off the top of my head, I don't remember. But basically, if you put a sequential gearbox in a Subaru, say X shift or whatever, it has a gear position sensor. It has that data coming back, so it knows when to finish upshifts and downshifts electronically. So we don't have that piece of data, but we have everything else. We have the estimates. It still revs it to the correct RPM, and as long as you make the downshift in a reasonable amount of time, you're going to be impressed with how good this feels on Emtron. It's as good as it can be without having that piece of data.
Yeah. Well, that's one of the things I'm really stoked for, because I know there's going to be time, and what this translates in is better braking. And if there's one weak point on Boogie, and even with as fantastic as EBC's been, and my new brakes that I've been running for the past couple of years, and the new tires that I'm on and things, Boogie is still, in the brake department, is still weak. And I, being able to just have being solidly on the pedal, and not having to worry about blipping the gas for a proper downshift, and that being smoother, there's going to be more grip all the way through. If I can upset the car less, there's even things I can find more time, because I am upsetting the car less. I don't have to set the car up to be so stable. I can set it up to be a little more unstable, just based on turning the car, and find more speed that way. So that's there's some exciting stuff there, because a lot of this, it seems like it's only this one piece, but no matter which way you look at it, a car is a system, okay? And if you change one piece of the system, it bleeds into a bunch of other things, and the end result with a time attack car is a lap time. So if I can, if when we're downshifting, I'm getting cleaner downshifts, and not having to heel toe. Without having to heel toe, I can keep my foot directly on the brake pedal. Being able to keep my foot directly on the brake pedal and my downshifts are going to be cleaner. That's going to basically mean I have more grip in the tires. So that should help turn in and mid corner quite a bit. And in theory, I should be able to get on the gas earlier, which is also going to be helped by the fact that now we're going to have more boost leaving corners. We don't need more power. What we're trying to do is use what we have more effectively. And I think this is going to be the answer.
Well, I'm happy you mentioned grip, because that gives me a good opportunity to talk about the next cool thing that we're probably going to try on your car.
Okay.
Now, given the fact that we're Subarus with all-wheel drive and DCCD, we don't necessarily deal with a ton of traction issues. But for the FT86 guys and the GR86 guys on Emtron eventually, this is super huge for them, and that's traction control.
Yeah. So this is traction control set up a lot like how Ferris is using theirs.
So here's one of the really neat things that they have, and I'm going to explain, is basically called G-speed traction control. Now that's not GPS. So here's the biggest challenge with, what do you think the biggest challenge is with trying to figure out traction control on an all-wheel drive car?
Reference to the ground.
Exactly. You've got, you're turning all four wheels. You don't have driven and undriven like a rear-wheel drive car to compare against.
Yeah. So it's going to be really hard to figure out if you're spinning the wheels.
Exactly.
That would be tough.
You have to have some other reference. Now, GPS speed is one way to do it, but it's not that fast.
It's going to be wonky.
At best 20 hertz,
Yeah.
So Emtron has come up with this concept called G speed, or basically G-force speed. They're using the internal accelerometer, and they're basically, it's really complex. And I've read over it many times, and I'm still probably not going to give a perfect explanation of how it exactly works. But long story short is, when the car's moving under certain conditions that are considered to be stable, you essentially keep resyncing. It keeps resyncing itself, the momentum to the car to the speed of the car, and it develops a linear relationship between what the accelerometer is seeing and how the car is accelerating or moving. Okay, and then when your vehicle speed changes, when your wheel speeds or your change, and they move away from that linear line of the expected acceleration from the accelerometer. In other words, when it feels that lag, best way I can describe this is when if you're accelerating and you lose traction,
if you're spinning, you're not going to have that forward thrust
exactly
like you normally would. Yeah,
exactly. So you stop being pushed back in the seat is the best way I can describe it. When you start spinning, you stop being pushed back in the seat. The accelerometer essentially measures that, sees that, and knows that you're spinning, takes corrective action to reduce torque and get those lines back together seamlessly.
That's like drag racing
what
stuff.
that's well, it is and it isn't. You know what this actually sounds like? This sounds like a very fancy version of how the Spider DCCD controller works. Because that essentially just uses a small G meter and it figures out how much lock you need in the center diff. This is taking this one step further. I almost wonder if we could use an output to DCCD to make it control DCCD using this.
Well,
I said it.
we are, one thing that we can do is we certainly can send we can use Emtron to control the lockup to some degree, leaning on the DCCD Pro to still do the majority of it. Yep. Well, that's a whole other conversation that we can talk about later. But
no, this is the fun stuff that you can do with some of these crazy things. Is like if you can come up with some bad idea to say like, I want this and turbo speed to somehow play into a traction control model, you can build that. That's just fun things you can do with standalones, and especially high-end standalones like this.
Exactly. So if we get to the point where we're turning up the power enough that you're struggling for traction, this G-speed traction control is something that we can leverage. So you can just put your foot down and the ECU will sort it out and give you what you can have.
Oh, God.
Oh, my gosh.
Yep. So what I want you to hear, Dylan, is we need 3 engines.
At least.
We need to we're just going to the moon, baby.
I think the IAG semi needs to make a comeback.
I didn't say it.
Yeah.
But
Dylan, get your CDL now.
I wish I could show you what I saw today. Man, we got some really cool stuff coming. Okay. I'm sure we'll have some social media posting about it. It's really cool. So we've got some really neat stuff coming. Dylan already updated the budget. Records and rods, baby. Yeah. So what's really crazy is, and this is, a lot of this stuff is crazy advanced, and I got to be real, your typical street car isn't going to use a lot of this, but the crazier we get with some of this stuff, some of it will actually trickle down. What we learn from a lot of this, the harder it may not trickle down the way you think it will, but the harder, say, we push this engine, because we now have the ability to use the traction and use the power, we're going to be able to make better engines. We're going to be able to, there's so much we can learn about this and different strategies for boost control, what is possible on particular size turbos, all sorts of things. this seems really wacky, but there is an effect that it does come down to your street car. This is why we push limits like this. So, and you learn new things, and let's be real, it just keeps it interesting. This is, I think it's wild that what essentially is one of the most basic time attack cars in street modified, as far as like complexity. We're talking plywood splitter guy here. This is what we're talking about. It's man, it's wild. We've come a long way, Graham.
We've come somewhere.
So keep selling me. You pretty much got me sold at this point, but keep selling me.
Okay. So we've hit the turbo modeling, anti-surge. We've talked about the throttle mass flow.
Yep.
Let's talk about the E-gate real quick. And that's
we haven't even trickled into that yet.
That's a two-part thing. And
yep.
First of all, I want to be clear that Emtron is not the only ECU that can control an E-gate. That's not special to Emtron.
Stuff we're doing with Boogie this year.
What Emtron recently added to their ECU that's pretty cool is that we're going to have on both our cars is we can control the electronic wastegate, get this, over CAN bus.
That's crazy.
Are you ready? Okay. Are you ready for that?
So that's not even going to take an input then.
Nope, exactly. So all it is going to be it's just going to be on the CAN bus, and it's going to leverage a Turbo Smart E-gate, and it's going to leverage the Turbo Smart.
Can you do me a favor?
Yes.
I want you to explain CAN bus real quick, okay? Because CAN bus is kind of a neat technology that we all hate.
We did CAN bus at the beginning.
We kind of did, but you really basically it's a protocol that everything can talk on, because like my gauge cluster runs on CAN bus, and it was literally just two wires and the thing lit up. It's two wires of power and the thing lit right up.
CAN bus is a communication network that OEM vehicles use to communicate amongst modules, just using two wires and transmitting tons of data. It's basically like having them on a network, instead of just a bunch of wires that talk back and forth. The network allows all these things to communicate seamlessly and fast. And motorsports ECUs are leveraging that now too. So Emtron, hooked up to an Emtron, you have CAN bus dash, you have CAN bus keypad for inputs. You have, the OEM CAN bus communications to keep all the OEM modules happy. You might have CAN bus to your ABS. You might have CAN bus to a high pressure fuel injector and pump controller, like on the GR86.
It's like USB for your damn car. Like literally, you plug it in, it just works.
It's like plugging everything into a USB hub.
Yes,
and that's how we can control the E-gate on these cars too. We're going to have the Turbo Smart black box controller is going to do all of the control. And it's going to provide all the power and take in all the information, and it's going to communicate the gate position, the gate temperature, and also take the input from the ECU of how much gate opening you want all over CAN bus. So it's just
I didn't realize that. So that electronic gate that actually has a temp sensor in it too, so it can relay temp sensor information.
Exactly. So if it's getting too hot, if it gets too hot, it'll shut down. But yes, you'll know the temperature of your gate too.
Yes. So, oh man, I got to get this mapped out of everything that we're going to need, because I got to get this to Emtron fairly soon. I'm literally over here holding my head going, I have way too much shit. But the fact that can run over CAN bus is phenomenal, because that doesn't
change anything on Emtron.
Which is awesome.
That's just getting the Turbo Smart E-gate and the Turbo Smart E-gate controller.
Yes, most standalones, with that stated, most standalones do support CAN bus. And their CAN system, like my Haltech, it ran, that's motorsports CAN, and
If I wasn't clear, CAN bus is not some special thing that only Emtron does. I didn't mean to say that at all.
And you clarified that. I just want to make sure that there's lots of stuff out there that it does work.
Emtron has some of the nicer end CAN bus customization. You can, in some ECUs, and I don't have this all in front of me, so I don't want to misspeak or anything, but I know with some ECUs it can be challenging to get and send things on the CAN easily and conveniently. I will say that with Emtron, it is really well built out, and you can send or get whatever you want. Like I have that AEM 4-channel AFR box on my car. I'm getting all the AFR information over CAN bus.
That's cool.
If something talks over CAN, it's I found it really easy to use Emtron to listen to it. In other words.
Yep.
Not
So
to say
what
other
James
ECUs
brought
don't
up,
do
he
that.
wants to. I think he caught this. So Adam was saying it's got a built-in EGT, and essentially yes, it does. But with that stated, James is right. That is not, absolutely not, a replacement for individual cylinder EGT, because that's going to take an average off of all four, and it's not even in technically a great position for it.
Well, hang on. It's not even that. It's not like it has a little baby EGT probe in the exhaust. It's not measuring exhaust temperature. It's got a temperature sensor inside the electronics area of the
to make sure you're not melting your
E-gate. Making sure there's not too much temperature and heat bleeding into the electronic components, because the last thing you want is an E-gate to fail and get stuck closed and you're sending rods out.
Yep.
So yes, so that's why the temperature, it's the temperature of the of inside of the wastegate control, not the temperature of the exhaust.
Adam just put it, it's really not EGT, it's more of an anti-Dewey system, which is probably true.
Basically, yes. And do keep in mind, you do have to run coolant through these E-gates.
Oh, do you really? Okay.
Yeah, well, it's not optional.
All right, well.
So that's for Dylan to worry about.
Yep, that's a Dylan problem. Okay.
Pretty simple. Pretty simple.
All right. Fuck. Okay. This is gonna be super cool. I'm so stoked.
Does the E-gate replace the boost control solenoid?
Yes. You no longer need a boost control solenoid. You no longer need a boost reference. Nothing's controlled by boost pressure anymore with your boost. It's literally controlled by an electronic valve.
Yeah, that's cool, because there's, I used to have nightmares with all of those lines running all over the place. And it's going to clean up some of that area of the engine bay, and it's just less stuff we got to worry about. I mean, I think Dylan did a great job of cleaning that up over there this year, but it's going to be real. One of the reasons we went to a single scroll turbo is so we didn't have to deal with that. The amount for two wastegates was nuts, and going to a single scroll that cleaned that up. But now we're going to get rid of most of it.
The other nice thing with the E-gate is you can go from 5 psi to 55 psi. There's no wastegate spring to change. So it's much more dynamic. We don't have to start with a pretty stiff spring to reach high boost pressures. We can run very low boost pressures at low throttle openings. So when when we're not dealing with anti-surge, when we're outside of that window, and we want less boost pressure period sustained, the E-gate can do it a lot easier.
Yep. Yeah, so that's super sick. That'll be really nice, especially considering your minimum boost doesn't have to be like, 18, 19 PSI. If we're on break-in, we can have 5, you know what I mean? And then if we want 40 PSI for whatever reason, you just tell it to do it. There's no springs, none of that bullshit. It either just works or it doesn't. I'm a big fan of digital.
Yeah. Now, James asked a good question. Does the E-gate have a default fail-safe, or kind of what happens if things shit the bed, let's say? Yeah. So E-gates do come with some risk. I'm just going to say it right now. E-gates come with some risk. You could make the argument that a pneumatic gate keeps it a lot simpler and less chance of things going wrong, because even if let's say a boost control line comes off of a regular wastegate, when your exhaust back pressure gets high enough, it'll open the gate. You won't go to necessarily infinite boost. Now, you still might hit a lot more boost than your engine can handle, but you've got more likelihood of survival. If let's say you melt the wires to your E-gate control at exactly the wrong time, and it's jammed all the way shut, spooling up, and you keep going, yes, you will reach some pretty high boost. Now, that's when your boost cut kicks in, your throttle closure kicks in, your torque management kicks in, and should take care of that before it becomes a problem. If you don't have some of that stuff in place, you might end up like that Honda that I think the whole top half of his engine came off on the line because his E-gate stuck shut. Do you remember that?
Yeah. So that's one of the reasons. Now we're going back into higher engine management. This is one of the reasons you might not want to mess around with some of this stuff.
Yeah,
but something basic or just a basic tune.
Aside from something like that happening where it gets stuck shut, and for some reason you don't have the rest of your safeties in place correctly to deal with that, it could be a problem potentially. Now, if there's a problem with temperature, it fails open. If there's a problem with position or communications, it will fail open. it's not gonna leave you in a position where you're screwed necessarily. And again, even if something does, if all else fails, your engine protection strategies should kick in and take care of the problem, before it becomes a bigger problem. So yes, E-gates do carry some risk, but E-gates with good engine management, it's pretty well mitigated risk in my opinion.
All right. Next, you got anything else? You've sold me, but is there anything like new and exciting about this thing that's from this step up that has got you amped up?
The only other thing before we jump into questions that I'll say was when I told you in the beginning, what's one of the other big selling points, and that is the data logging throughput. We can log some significant amounts of data at some significant data rates that make it really helpful for seeing little instances of, like, let's just say on the knock sensor, we have a really good ability to look for engine knock on the Emtron that's not so strong on other ECUs. It's same thing for like certain pressures, certain other behaviors on the map sensor, RPM, crank signal, all these things. Even the way that the Emtron monitors the crank position is really good. I wish I had the details on the hardware to compare. I don't really have all those, and they didn't really want to give that to me. But bottom line, Emtron essentially sees every tooth on the crank sensor, whereas some other ECUs, and again, I'm not going to speak specifics because I don't know the specifics, but some other ECUs have to basically do some dividing to sort of work it out, if that makes sense.
It's basically doing some interpolation.
It's sort of doing some interpolation because they're not processing fast enough to actually keep track of the individual crank teeth. Okay.
Yes.
And I learned this recently because when I was working with that 16 STI, I was having some funny behaviors with his car and another car where it would lose track of the RPM. And I talked to my guy over at Emtron, and I showed him everything I was doing, and I'm like, "What's going on here?" And he goes, "Oh, you have your trigger voltages way high." He goes, "Where did you get those values?" I'm like, "Well, these are what I've used on other ECUs." He goes, and he laughs and he goes, "Well, those are other ECUs. You don't need to be that high a voltage." And I'm like, "Oh, really? Why is that?" And basically, it came down to the fact that the Emtron actually sees what's going on the whole time, whereas other ECUs, you sort of have to raise that threshold essentially because it's easy for that noise to happen in between, if you will.
Yeah.
And I was like, wow, okay, that makes sense why I've noticed that the graph, when I look at a dyno graph on an Emtron, I'm like, why is this seems so much smoother even at the same settings I would use on anything else? Why is it so much smoother? And he said it's because we're keeping track of the engine position more accurately.
That's really cool. And that's one of those things that data, people have said, trash in, trash out, I guess is a good way of putting it when you're trying to make, and I'm not trying to say that these other ECUs are trash. That's not what I'm trying to get at. But the less accurate your data is, the less accurate your decision making and outcome of what you're changing is going to be.
Yep, exactly.
So that's
it's all about being as accurate as you can for what you can afford. We can't afford to put Bosch Motorsports ECUs in these cars. We just can't.
No, but so like Emtron is not. And let me make sure people understand this. Emtron is in most like super high end motorsports. We're talking like IMSA, IndyCar, Formula One, things like that. They would look at IMSA the way some of us, like how you and I were kind of. Or they would look at Emtron the same way you and I were looking at that thing that was in the those race cars. What the hell are those things? The Sakers.
Yep.
You know what I mean? Like they're just different levels of this, and
wild.
I'm not gonna lie, this is getting into high end grassroots, and low end, like more of I don't know, prosumer. Is that a good term? Like I don't know what term you would use for this, but
essentially the feeling I've gotten is that a lot of this modeling that they've done and a lot of this control they've done actually comes after looking at how Bosch OEM ECUs control cars. So like the ECU that you find in my RS3, in a Porsche 911 Turbo, they have this throttle math flow. They have pressure sensors before the throttle, after the throttle. They have all these extra sensors that we're going to put on our cars. And that's why those cars feel so amazing no matter what you do with the pedal. You can be a complete idiot with the pedal, and the fueling is always within 5 or 10% correction. And it blew my mind. I'm like, how are they doing this? This can't be speed density. They don't have map sensors. How are they doing this? And the answer is they're doing the calculations the same way Emtron is. That's how Bosch does it on the real high-end $300,000 cars that you can buy from Porsche. They do it using these models.
$300,000 cars and, $10 million race cars are probably doing, I bet you Formula One uses something very similar. Because things like mid-throttle, it really, really matters in Formula One, you know what I mean? Or IMSA or something like that, where you have to calculate things like that. And, it's instability like that will put your car into the wall. So, I think we need to open it up to some questions. Okay. We got a lot of new people in here, and this is fantastic. And I want to let you guys know, I can't tell you how much I appreciate you guys showing up. You have a couple of ways to ask questions. You can either ask it in the chat or you can raise your hand. Okay. You can ask to speak on stage, which is raising your hand. I'd be more than happy to bring you up here. You can ask your question. We'll answer it to the best of our ability. And this is pretty much open table time. So feel free if you got anything you want to ask. I'd kind of like to keep it on topic, but we can venture a little bit. I'm down to clown. And this is your time. I think there are a couple of questions a little further back that we may have not gotten to. I'm kind of digging. But this is we're wide open here. So Logan, I really appreciate you guys, by the way. Super appreciate all these new guys, and we've been trying to do this every week, so listen to some of our older content too. We got some good stuff. Not all of it gets quite this off the deep end. A lot of it is just basic Subaru content, which is a lot of fun. Some of it's just hanging out. But we love having you guys. Dual ECUs have entered the chat. I won't discuss that more. Okay. Adam, can you run individual cylinder EGTs on this ECU?
Yep, easily.
Yeah.
Yep. And most
I'm running that on my Haltech. So
yeah. That's not something that's special. No, pretty much any aftermarket ECU can do that, which is cool.
Yep. And then even AEM way back in the day, they had separate units that you could plug in, even in some of their more basic ECUs that you could do that. But I tell you what, it's worth it. Brother, you could do that with a Cobb back in the day. There's actually some things you can. It's really. I'm going to kind of venture into this while we're waiting for some more questions to build up. One of the reasons we're starting to see a resurgence of a lot of standalone talk these days isn't really due to the EPA. It's more due to the fact that Cobb was so good for so long, it was very hard to justify making that jump. A lot of us, you could make 1,000 wheel on a Cobb. You could, your street cars were ridiculous on a Cobb, and a lot of track cars were great on a Cobb. And like our basic ECU options, because our stock ECUs were really good, we were able to do so much stuff with these, and it has gotten a bit more limited with what you can mess around with a Cobb, that it started to affect the motorsports side of stuff. That's when we started looking at more standalones. There is some really cool stuff in development coming from that, because Cobb kind of doesn't have a stranglehold on the entire market now. So we're starting to see some really new and interesting things. Link, I talked about it a few weeks ago, has got a plug-and-play ECU coming for the GR86 that literally just drops in, which is super cool. The other thing that I thought was really neat, Emtron actually is talking about doing an 08 and newer plug-and-play. U.S. domestic market plug-and-play. That's 08 all the way to 21 STI. Plug and play, drops in, use your stock wiring harness. That's been quote unquote green lit. I have no idea when that's coming out, but you're hearing it first here. Which is super cool. Like, how awesome is that? And we're starting to see more of this stuff now, because there isn't such a stranglehold. A lot of this stuff existed in other markets, though, didn't exist here, because in other markets, Cobb didn't really have the full lockdown on everything. And our ECUs do have some slight differences. It's pretty cool. We got some really neat stuff coming. Adam's over there crying in BRZ. There's no reason to cry in BRZ because I think some absolutely fantastic stuff is coming down the line, especially for the FA guys. Because the jump from BRZ to say 15 plus WRX isn't as big as you would think when you're coming from a from a standalone ECU side of this. It's some wiring and some approach, but it's not as far off as you think. Controlling the direct injection, working with a CAN system is all really similar. So there's some really, really exciting stuff coming in the very near future for a lot of these guys that is going to open up a whole new thing for your track car that you want to make sure drives really nice in the pits. Hold on. What do we got? Do you got anything you want to add on that while I'm digging up new stuff?
No, I don't think so. I think you got
all
it
right.
covered.
Chris, when it comes to safety setups for Emtron, what would you recommend from easier to implement to more difficult? I think this is just with all standalones in general. I mean, a lot of these.
Here's how I usually do things. So standard, if you're going to move to an Emtron, I always sell at least. I mean, let's assuming you may already have a fuel pressure sensor. Let's say you had an existing Cobb Flex fuel kit and you're on your car and you're ready to take your car to the track and you want to go to Emtron. We would utilize the existing fuel pressure input, and then we would have a new connection for your flex fuel sensor direct to the ECU. Additionally, I always say to add oil temperature, oil pressure, and coolant pressure as bare minimums. Those are all things that are easy to plumb in, easy to set up, and relatively low cost that are good pieces of information to use for safeties. If you want to go to the next level, if you're trying to be very competitive or really, really high horsepower stuff where per cylinder becomes extremely important, more so than it already is, then 4-channel EGT is another piece that I always recommend adding on from there. Then if you're trying to go to the level like your car is, then we start talking about the turbo dynamics pieces and adding those types of sensors. The other thing I'm doing more now is I'm making it more, assuming somebody is on a front mount setup, and it can be done top mount, is I'm having people do the pre-throttle body pressure sensor. That allows us to do the throttle mass airflow calculations for part throttle. So that's become pretty standard too. So that's kind of the order at which I recommend adding things to take advantage of what you can.
So I think you kind of covered up what Josh asked too. He's like, to maximize data acquisition, what sensors should be added to maximize my Emtron experience? You basically just went over that. Now, again, The harder you go, the more sensors. Yeah, there's no such thing as. I forgot to mention exhaust back pressure. Exhaust back pressure is a really good sensor to have too.
Huge
for us this year. Huge.
We use that a lot. We use that a lot to know where your turbo was at in terms of efficiency.
We learned a lot off of that this year, and we went from scary not reliable to surprisingly quite reliable. I mean, the only thing that really killed our engine at the end of the year was me. So and
I can't tune you from shifting into the wrong gears on the H pattern. Sorry.
Can you turn down the money shift tables for me next year, please?
We can put a sequential gearbox in it and put you in track mod.
Yeah, but that's lame. Street mod's where the war's at. All the kids played street mod.
We're in the right gear, bud.
Yeah, I'll do what I can do.
Okay.
Ryan asked, so on the BRZ note, how does Emtron deal with direct injectors and better DI and port?
Yep, so I can answer that. So on the FT86, the FT86 ECU already doesn't control the direct injection directly. There's a secondary controller that mounts up next to the engine that runs the DI pump and runs the DI injectors.
So we're talking first gen BRZ and FT86. Okay.
FT86. I'll call it FT86 for clarity and GR86 for the other one, for the newer one.
Sounds good. Okay.
So the FT86 has a standalone DI and high pressure pump controller. And when you plug an Emtron plug-in ECU into those cars, it controls that controller, just like it would stock. What we're going to be doing for the the GR86 is either Emtron's still working on this, but there's going to be a secondary controller that the Emtron controls, just like because the GR86 ECU does directly control on those cars. There'll be a secondary controller that Emtron talks to and controls.
So that's Okay,
That's
so
the answer. And to answer the question more directly, at this time, Emtron doesn't offer any ECUs that can directly control a direct injection pump. That part wouldn't be so hard, but more importantly, the DI injectors. DI injector control is kind of tricky. It requires specific drivers and specific pieces of hardware that Emtron hasn't built yet. They may at some point, but using a secondary controller is obviously works fine. It works well enough that, Toyota and Subaru did it OEM on the FT86.
So Ryan's saying, I thought Graham had mentioned a math model in Emtron, but I think I misinterpreted the description of the throttle SD speed density model.
Yeah,
Not
they
sure.
have a throttle. They have throttle mass flow, which is using the two pressure sensors and the throttle plate. They can use a MAF sensor input. You could, if you wanted to, use the MAF sensor to calculate your airflow if you really wanted to. It exists to do. It's not necessarily common or to use, but it could be done. There's actually a car that I started tuning remotely, and we actually started with the MAF model, and it worked great. And then he made some other changes, and we moved to speed density, and it worked even better. So.
Yep.
Quick question from the chat: how does
Yep.
your experience with open source ECUs differ from these high-end closed source ECUs?
Well, open source is still a stock ECU, so you're still
Yeah.
bound by all the same limitations as you are.
The question was open source standalone, such as Speeduino, which I think is an Arduino.
Oh, okay. No, yeah. So I've seen some of those coming around.
Is this Tony's question?
Yeah.
Yeah.
I've seen some of these coming around. I've looked at them on a high level. I haven't dug into them and tried to do any tuning with them. They look kind of interesting and neat. The problem that you're going to run into with open source type stuff like this is you're going to have to DIY the firmware and the controls yourself in a lot of cases. Not all the cases, but the benefit with the Emtron is that all of the firmware is written for you. You just jump in and turn things on and away you go to some degree. Some of those open source ECUs, yeah, it's a black box, but you have to go even deeper than we're already going with a standalone to take advantage of it. I think that might be the challenge there.
I think really what it comes down to is this is one of the advantages of capitalism. If you're making money off of what you're providing, more than likely you're going to be able to hire people to try harder to make more money. I mean, it really comes down to that. So I think open source and community source things definitely have their place. But if something you pay for is probably going to be a lot more polished experience. Now, there are situations where there are some extraordinarily smart people doing some extraordinarily amazing stuff with open source based things. And I mean, hell, for years, we did some amazing open source stuff with stock ECUs. And this is the same thing that trickles over into the standalone ECUs. Don't get me wrong. There's probably some amazing things you can do with it. And there's probably some situations where that might actually be your best option. But if you can run something like an Emtron, you're probably better off. Or, even a Haltech Link, a lot of this stuff's already built out for you.
Yep, exactly.
Okay. Kyle's got a great question, and I definitely want Graham to pop in with us too. How much back pressure were you seeing that became problematic? Basically, what he's trying to ask is if we want to share specifics on that. And I've got no problem talking about it.
Yeah, James answered it pretty well. And I don't have the data in front of me. I'm not really prepared to be able to say what we were seeing. I can't remember. But James made a very good point in there. Generally, you don't want to go past 1-to-1. You don't want your back pressure to be exceeding your manifold absolute pressure. So in other words, if you're at, let's say, 40 psi and you're at sea level, that's about 54.5 psi of absolute pressure. If you're looking at the EMAP and you're seeing 60, 65, 70, you've got a lot more pressure on the exhaust side than you do on the manifold side, and you're going to be operating pretty inefficiently at that point. So that's the answer there. You don't want to get much past 1-to-1. So if you're trying to go to a boost level and you're not getting there without having a lot of back pressure, you might want to try a bigger exhaust housing like we've tested on your car. And if that's not doing it, then you might need to go to a bigger turbocharger for your engine. You might be undersized on your turbocharger.
Yeah, which I think we were running into some issues with back pressure, even though we had a fairly large turbocharger on the car. The twin scroll setup and how that was, we are pretty sure that was one of the big issues that was causing a lot of the reliability problems and making our exhaust manifold freakishly hot. On my old setup, that old twin scroll setup. I don't think there's anything against the Borg. It's just what we were asking it to do within that situation. I don't think it was a great match. I think that setup actually probably would have worked better in a single scroll setup. But yeah. And that's why we went with the size hot side we did. I'm trying to remember, what did we end up on, the 1.2? Yeah, it was a huge hot side.
The 1.21, and we gave up some spool, but we definitely did pick up some top end power on your car.
Yeah, and we do believe that was due to some pressure, and it really wasn't worth. We were more interested in the reliability side of that than the power side of that. Just so we could make the whole season. So we decided to go with the bigger hot side because what we gave up wasn't worth it for the pressure that we saw increase. So, and all of that was learned through pressure sensors, which is something I didn't have until this year. So, secondary control, okay, cool. Jordan, I've seen some drag racers use a second gear lockout, so you can't money shift. However, I've seen them with manual unlock pins, so that's not useful. Yeah. Unfortunately, a second gear lockout might be cool, but then there's situations where I'd kind of like to get in second gear. Plus, realistically, my third to second would have been the same thing if I went, I guess there's not very many instances where I would be looking to go grab sixth and grab fourth. Maybe there is a mechanical thing to keep me out of second. I don't know.
Not a bad idea, especially if it was like it's relatively easy to grab when you you need second for some reason.
Yeah. I don't know why I would of no track that we would go to, can I think of I can think of one, but
Hey, yeah, I got it. All right. Looking into it. Okay. Hopefully Dylan's paying attention. Okay. So Dylan? what we're going to do, and again, this isn't like anything special that Emtron can only do, but we're going to utilize a custom output on Emtron to run a solenoid that locks out second gear above certain speeds.
Well, how are we going to lock out? We could make it just a physical thing that once I get moving, I just click the thing so I can't get into it.
Hey, slow down. It would have to be something designed around the shift linkage to basically not allow you to select the 1-2 gate above a certain speed where you'd never want to.
Man, getting that dialed would be so hard, but it'd be cool.
It could just be like some sort of like a pneumatic, little protrusion that comes out. It just comes out and it locks the stick from going to the 1-2 when you're above a certain speed. I mean, how hard could it be to design something like this?
The way to do it would actually be something set up to block that for your shift finger from going over on the inside.
In the transmission?
In the trans wouldn't be, because how that works isn't very hard.
The challenge is if trying to implement that means pulling the transmission, taking it apart, adding that on the inside. If you could implement something on the linkage to prevent the linkage from going in the direction that is the 1-2 gate above a certain speed, is that not a simple solution?
It is, but you would also have to think about the amount of slack that is in our.
Dewey, you just drive the car. This isn't a problem for you. This is
Dylan gets a fucking mathing.
Listen, I tune it. Dylan builds it. We save you from yourself, and you win.
Okay. Well, we will think about this.
It's not the first time people have just invented really good solutions for.
I mean, that's true. Okay. James, AM EMS-4 is my favorite ECU. Mega Micro Squirt, he's screaming all sorts of crazy stuff in here. I love James. For old like B series Hondas and stuff like that, some of those older ECUs did the job. There's something to be said about an older, simpler engine that we're not trying to do like completely wacky shit with. And a lot of what we're trying to do may not make sense for like a drag race setup at all. You know what I mean? Like at what point in a drag situation are you running partial throttle? That's partial throttle stuff is where this starts getting wacky. And in my situation, it's a different animal.
Towards the wall and you're trying to save it.
Yeah, which you got to ask yourself, is the juice worth the squeeze then? And for me, totally is. For a drag car, even our crazy drag car, it may not be. Tim's talking about how he's tuned a few Turbo Miatas on Mega Squirt 2 and 3, and it's okay, but leaves a lot to be desired, and that's that. A lot of that comes down to the firmware that exists in it. It isn't that the hardware itself is bad, it's the software and, the user experience on that end can be a little rough. So, James, we don't talk about Infinity. Okay, what else do we got? I'm trying to catch up a lot. The chat got really fast for a second. Do we have any other questions? Yeah, I was curious, since I'm planning on running the 8474 twin scroll, Dewey was pre G35. Again, I think a lot of that has to do, Kyle, with how that was running on my car in particular, and some of it had to do with the exhaust manifold. That turbo was great to me, and with that stated, man, we beat the shit out of that turbo for years. Graham will attest, my 8374 and 8474, I never had a turbo failure the entire time. I beat the shit out of that. Boost leaks, all sorts of crap, overspinning the hell out of it. It never failed on me.
Yep. Those things they don't take quick changes in shaft speed, so they don't really like drag race flat foot shifting with Cobb tunes on stock ECUs. That's when I've seen them come apart. But for our purposes, it was fine.
Man, you ran one for years. You never had a turbo failure. We always, and the bearings are always good. Like we never had a seal shit on us. Like they were great turbos.
The challenge with the EFRs is they just never made the power that we expected they could. They just they were so good. They were so good, but they did not punch at their turbine wheel size. They just didn't, for whatever reason. They were really good, but you had to keep going bigger and bigger to get what you wanted for power. And even then they just, for what we were trying to do for time attack purposes, it wasn't quite the right option. Garrett is giving us what we're looking for there.
Garrett's really, really working well with what we're trying to do.
Yeah,
and I think some of that is sizing. And I think that may work out phenomenal for Kyle. It's just Subarus are kind of an inefficient engine, and a more efficient engine will probably work better with it. Look at Will All Young. Look at all the shit Will All Young's done. He's been with Borg forever, and Will All Young has set how many records on random EFRs? Will All Young's a very good example of if you got an efficient engine, you can do some amazing stuff. And there you go. I'm not saying that EFR is a bad turbo, and it didn't work for what we were using. And it did actually work. I shouldn't even say that it worked. It just the Garrett's working better. So yeah. Damn drivers trying to make suggestions. Yeah, you shouldn't let me make suggestions. Holy crap! I am literally trying to catch up. This turbo this chat got crazy. What screen do you guys like for an Emtron? Okay, I can dive into this a little bit. It really depends on what you're trying to do. Okay, I really like my aim dash, but my aim dash has limitations. There is some super cool stuff that the new Emtron dash can do that honestly really makes me stare at that just because of the customizability of it. Now, if what you're doing is drag racing, a lot of the stuff that I like about AIM doesn't apply. So it's really get what works. Hell, even that AEM dash, you can do some amazing stuff, and the price of that thing is incredible. But some of those higher end dashes, boy, you can do some really, really cool stuff, especially that Emtron dash. Like we were talking about it the other day, they're implementing GPS-based, lap-based boost control strategies. So this is some more crazy stuff I really like about Emtron. is, let's say we're coming, we don't want the engine to go nuts, but man, we really need to get down the back straight mid-Ohio a little quicker. We're going to turn her up a little bit just for the straightaway. It has the ability to know we're on this straightaway and can give us more boost. Or maybe we're having a problem like, hey, we're coming out of this corner a little ugly. Maybe we can dial the boost back just in this area to give us a little more control, and then we haul ass down. This is all stuff you can do with Emtron that I haven't seen other companies make specifically for that. Now, I'm not saying you wouldn't be able to build this into something else through, that's one of the cool things you can do with standalones is if you have this input and that input and that input, you can overlay it. But this is like built out already, which I thought was super cool. But it really depends on what you're trying to do as to what dash makes sense to you. I really like the AIM due to the data on the back side of it. AIM, even though it's not very customizable, almost every track organizer or track coach, and you're trying to overlay data and data program can take AIM data and do something with it. So the data coming from the AIM dash itself is really helpful for somebody on the track side of stuff. But if, like I said, if you're drag racing or something else, or you need something a lot more customizable, you may want to look into something else. I don't know if you've got something to throw into that. Graham, both you and I are running AIM dashes, and we both kind of have some of the same issues. There's some limitations with AIM that piss me off to no end.
The super cool thing is there's a lot of really cool dashes out there these days. In my STI, because I need all the CAN bus stuff to work, that theoretically could be done with the new Emtron dash. I just don't possess the skills or know anybody who does that can put it all together to make all the OEM stuff work correctly, to take out the OEM dash. So I leaned on Corbin Johnson of Johnson Tuning to build me a Motec C127 dash replacement that communicates with the Emtron perfectly, works on the CAN bus, has all the cool Motec things, but he has all the CAN bus stuff done for it. So all the OEM stuff works correctly. So I'm running a Motec dash now. We have AIM in Kim's GC previously, working with the Link ECU, and it's amazing. But I think we're going to change her over to this fancy new Emtron dash. We're going to put that fancy new Emtron dash in the GC. That whole GC concept is going to move to Emtron 2. And it's going to be sort of leave it as OEM GC looking as we want, or as she wants it to be, but with cool technology under the covers. So that's our plan for that part.
That's super.
I mean, dashes in the past 5 years have went crazy. There's so many epic options.
They're looking like OEM
it's the same thing
now.
with PDMs. It was like dash and PDMs went nuts in the past 5 years.
Yep.
So, what do we got? I ran EFR solo because I got it on eBay from an IndyCar team. Nothing wrong with that. Kyle, so the response, so good response, but not power for the wheel size. Yeah, basically peak power wasn't great, but man, I got to be real. That EFR responded like nothing else.
That part of it's really good.
I am sponsored by Garrett. Okay, and so this may not, but I tell you what, that on-off throttle response from an EFR, that turbo comes back lightning fast, and a lot of that has to do with how light the wheel was. But that was also some of its downside. If you overspin that turbo, bad things happen. So it's you're gonna, there's trade-offs with everything. With everything. So Tim, they got into talking about precisions and some of the stuff for drag racing. I'm still one of those people. For drag racing or a street car, precision's probably great. There's a reason you don't see a lot of precisions on track, and a lot of it has to do with there's a difference between boost threshold and lag, and people can say what they want, but precisions, from what my experience has been with them, they're phenomenal at making power for their size. And the boost threshold's phenomenal. They look absolutely fantastic on a dyno graph, and they work great for drag racing. They're not the greatest road course turbos.
Yeah, they lack in transient response a bit, and then they only have oil cooling, which can be challenging. In road racing, water cooling is pretty helpful. Not saying they can't survive. There's cars that have used them for short little stints, but you might have to limit your laps. You might have more wear and tear on them without the water cooling, maybe.
Yep. So, can you make an Emtron dash look like an RA 10,000 RPM DCD cluster? So, Ryan, kinda, yeah. I mean, that's the cool thing you can do with some of these other dashboards that you kind of can't do with AIM is you can customize the living shit out of it. The more expensive it, but just get ready. It's going to take time and it's going to take effort, but they're pretty wide open. So simple 500 horsepower build suggestions. Depends on the car, Logan. That actually is something that I think I want to have a conversation with. I think I'm going to bring James on. We're going to argue about the right way to make 500 horsepower on every car. Like every different, like 5 layouts, how to make 500 horsepower on that in the different approaches to it. I'm sure Graham's going to scream from the sidelines when we're saying some of this stuff, but it's going to happen. So if you want to have that conversation, Logan, totally down with that, because it changes depending on the car to a certain degree. Okay. And there's 500 horsepower and then there's 500 horsepower plus the other stuff that needs to go with it. Dylan says C6 vet, get a cam and heads. Okay. Like I said, different cars. But what you need to make 500 horsepower on an old Bug-Eye is different than a 2017 STI, and like it's not too much different than a 14 WRX, except how long is that trans going to last? There's considerations. And then we also have the conversation about 15 plus WRXs or a BRZ. We had a post the other day of basically VA STIs in the fast 5, like this is how you would make 500 for set amount, and most of us agree with it to a certain degree. There are some things that maybe some of us would have liked to see changed a little bit, and I think that, but it really stokes some interesting conversation, and I think that's going to be for a here in a few weeks. I've got a couple of people I got scheduled, and I think that's going to be one of our conversations we're going to have in the not too distant future. So I definitely want you guys to tune in for that. That'll be a fun one. We got some talk about Hiroshima hair blowers, all sorts of stuff. Yeah. Anybody else? We're still open for questions. If not, man, we've been going for almost 2 hours, but I think this has been an absolutely fantastic podcast. I definitely got to thank Graham and Warranty for being on. Warranty, I know you didn't get to talk a whole lot, but I think what you did say definitely added to it. And Graham, I know you just talked your brains out, and we appreciate it.
Yep, I'm ready for a nap. Maybe
Dylan wants in real quick. We're gonna bring Dylan in. And
this was some high scientific shit.
What up, D? You're on mute. Oh, James wants in too.
Hello.
Or let's end it on a high note. James, what's up? Dylan, you're on, but you're on mute for some reason. There you go.
Hi.
Say your piece.
I just want to say hello. That was it.
Oh, hey, what's up, dude? James, I think with all that discussion that happened the other day of the 500 horsepower post, I think you and I are going to have a how to make 500 horsepower with different vehicles. I think you and I should have that talk. I think it would be fun. And I think we both would probably have slightly different approaches. I think it'd be a good time. So I think maybe I'll lay out like the different cars and you and I will approach 500 horsepower differently and why we approach it the way we do.
Oh, there's so many different ways to do it depending on budget and how you want to go about it.
And
I mean, I've done it some sloppy ways. I've done it the
There's just some really ugly ways to make 5.
Oh yeah,
I want in on that conversation.
Sure, why not?
You could do some nasty shit and have a ball.
Yeah.
I mean, it's really up to what you like doing. I don't care if you want to do it the correct way, you want to do it the wrong way. Like I said, I've got a tuner in the chat, and he's gonna hate me for saying it, but you could do so much garbage and just have a great time for a limited amount of time. You're here for a good time, not a long time with that stuff. But I don't know. We could have fun with that.
Yeah. That's a totally different conversation though, and I don't want to elaborate too much on that.
Oh yeah.
So, Dylan, you got anything you want to say real quick?
Yeah, I just wanted to say that if you blow the engine at the track, I'm taping the hood shut with orange tape.
Oh no! Stay the fuck away from it with that orange garbage. God.
Yeah, I'm gonna hang it on the wall in the trailer.
I'm so mad that our best pictures from Lime Rock have orange tape all over the damn car. It looks like ass. So
We ran out of black tape though.
and God, it looked ugly. But
You
we
were
had some
so
great
mad.
pictures. Oh, it looked like shit.
So mad.
Oh man, whatever. All right. Well, we're gonna have some. We should talk about, and I think we should get into some of the junkyard bad idea shit that we've done back in the day too. I think that'd be a fun conversation. Yeah, we'll bring Dylan in. We'll bring James in. Hell, if Graham wants to join in on that and he can just be mad the whole time, that would be fun.
Yeah, no, I'm okay with that. I do some dumb stuff. Let's go.
If you want to get into the grimy shit here at IAG, I'm your guy. You're gonna do some sketchy shit. I enjoy that more than anything else.
So let's
Well, I mean-
let's plan that for not 2 weeks, but 3 weeks from now, because I have to talk to Ryan next week, and then we're gonna have the one and only DRP, the king of we're gonna have, God, why is my brain fucking
Rick
turning
Wilson.
off right now? Yeah, we're gonna have Rick Wilson on, and it's gonna be a really good time. So
Yeah.
that'll be an interview that I don't have to try very hard. That'll be fun. So, all right, let's reconvene. This has been great. Thanks, guys. Thanks for helping out in the chat, James and Dylan. Both of you guys are doing a great job, and we're gonna end it right here. So this was awesome.
All right. Have fun.
All right, bet.
All right, see you guys.
Cool.
And again, this will be going up on our Spotify, and we're on Apple now. Holy shit! That was so hard to do. We are on Apple. Do us a favor though, share this, guys. It really helps us a lot. And we'll be here next week on Thursday, so it's going to be a really good time. Come back, and we'll chat, and this will be great. I'm super stoked to see the amount of new people that were in here. That was killer for damn near 2 hours. It's awesome. So we'll see you next time. It's been real. It's been fun. It's been real fun. Let's do it again.